Okay, understood the meaning of phase? Phase is just a state of vibration of a particle, and phase difference gives the difference in the state of vibrations between the two particles. And next comes is the path difference. Path difference, the symbol is delta x. See, to understand the path difference, let us imagine the two light sources. Okay, I'm taking the two light sources somewhere here. So this is the source 1 and this is the light source 2. And we have to project to the point P here. Okay, but the point P is very closer to the S1 and it is little near, a little far, right, for the source S2. See, this is the S2P is the longer path. S1P is the shorter path. If you want to find what is the difference in these two paths, just plot a perpendicular line. Okay, then you will come to know the phase difference. So this is called delta X. Understand? The phase difference between the two light waves, okay, or the two waves to reach a given point. It is the difference in the distance traveled, in the distance traveled by the two waves in reaching a point. In reaching a point. And what is the relationship between phase difference and path difference? Very important. The relationship between phase difference and path difference, we can write like this. Delta phi is equal to 2 pi by lambda into delta x. So very important formula. By using this formula only, we can understand the interference concepts. Okay. Yeah, please make a note of it. Interference of light. See, the interference concept we study through the wave nature of light. The meaning of interference is nothing but, see, when we project a two or more light waves to a common point. Okay. So when you project the two or more lights to a common point, the intensity of the light, so it appeared to be brighter, right? It appeared to increase. So meanwhile, we can also decrease the intensity also by using the superposition of two or more waves. This is what we call as a redistribution of light energy. Okay, so either we can increase the intensity or we can decrease the intensity of light by combining the two or more light waves. So this phenomenon is called as an interference of light. Okay, so we can define like this: interference of light. It is the phenomenon of redistribution of light energy due to superposition of two or more waves. So in this interference, we can see there are two types of interference. Okay, the first one we call it as a constructive interference. Constructive interference meaning is, see, in this interference, the intensity of light is, the resultant intensity of light is very high. Okay, so that we can expect the bright fringes when the constructive interference occur. The reason is very simple. See, when we have taken a two waves, so I'm taking the first wave here and I'm taking the second wave. So observe the crust and troughs there. So you can see this is the wave 1 and this is the wave 2. Y2 I'm taking the displacements. So the resultant means you can see a crust falling on crust, trough falling on trough, crust falling on crust, trough falling on trough. ಓಕೆ, ಒಂದರ ಕ್ರಸ್ಟ್ ಮತ್ತೊಂದು ಕ್ರಸ್ಟ್ ಮೇಲೆ ಬೀಳ್ತಾ ಇದೆ, ಇನ್ನೊಂದು ಟ್ರಫ್ ಮತ್ತೊಂದರ ಟ್ರಫ್ ಮೇಲೆ ಬೀಳ್ತಾ ಇದೆ. ಈ ರೀತಿಯಾದಾಗ ಏನಾಗುತ್ತೆ, ಆ ಎರಡೂ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ಸ್ ಆಡ್ ಆಗುತ್ತೆ. ಸೊ ವೆನ್ ದ ಟೂ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ಸ್ ಗೆಟ್ ಆಡೆಡ್, the resultant crust and trough will be very great, very big one. Okay, so this indicates the resultant displacements are added. Y is equal to y1 plus y2. So that intensity of light increases here, it will become maximum. This is the constructive interference. Okay, I can write the constructive interference, the explanation like this. When crust of one wave falls on crust of the other, or trough of one wave, trough of one wave falls on trough of the other, then their resultant displacement, resultant displacement get added. So you can see that y is equal to y1 plus y2. Okay. Hence, the intensity of resultant wave becomes maximum. Intensity of resultant wave becomes maximum. Okay, so the result, we get the bright fringes. Bright fringes. Okay, this is about constructive interference. So this type is quite opposite to the first case. So your crust falls on a trough, trough falls on a crust. So I can show in a wave nature like this. This is the wave 1. I'm taking as a y1. The next wave. Okay. So here. 1 minute. So at the crust position of the first wave, we are getting the trough. Like this. And for the trough of the first wave, crust is coming. Like this it comes. So this is the y2. So the resultant will be subtracted. Okay, so we get very minimum value of cluster trough. Okay, observe the resultant, it is very, very small. So it is y1 minus y2. Got it? So almost we can expect the zero if the displacements of the crust and troughs are equal in both the waves. We can expect the zero displacement of the resultant. Okay. So it leads to the darkness. So the destructive interference gives the dark fringes. So we can write like this: when crest of one wave falls on trough of the other or vice versa. Okay. The resultant displacement get subtracted hence intensity of resultant wave becomes minimum. Intensity of resultant wave is minimum. Okay, minimum means it gives the dark fringe. This is the information about destructive interference. Examples of interference. Examples of interference. So ಏನಿದು ಇಂಟರ್ಫರೆನ್ಸ್ ಅಂದ್ರೆ ಎಲ್ಲಿ ನೋಡಬಹುದು ನಾವು ಇಂಟರ್ಫರೆನ್ಸ್ ಅನ್ನ? ಸೊ ನಾವು ಯೂಶಲಿ ನೋಡೇ ಇರ್ತೀವಿ ಸೋಪ್ ಬಬಲ್ಸ್, ಓಕೆ, ಅಥವಾ ಆಯಿಲ್ ಫಿಲ್ಮ್. ಎಣ್ಣೆ ಏನಾದ್ರೂ ನೀರಿನಲ್ಲಿ ಚೆಲ್ಲಿದ್ರೆ ಅದ್ರ ಮೇಲೆ ಕಲರ್ ಪ್ಯಾಟರ್ನ್ ನೋಡ್ತೀವಿ, ಹೌದಾ? ಸೊ ಅದೆಲ್ಲವೂ ಕೂಡ ಏನಾಗುತ್ತೆ, ಇಟ್ ಈಸ್ ಡ್ಯೂ ಟು ದ interference concept. Okay, due to the sunlight interference, so we can see the color pattern on the soap bubble and on the oil films. Got it? The example we can tell that color pattern observed on soap bubble and on oil film. Oil films are the examples. Okay, oil films, especially when it is on water. Okay, on oil films on water surface. Okay. Next, about the sources of light. So there are two types of sources of light. One is the incoherent sources. Incoherent sources. The meaning of incoherent sources of light is nothing but it emits the light waves of different wavelength at different state of vibrations. Okay, there will be a phase difference. Okay, and there will be a path difference, and wavelengths are different. So this is called the incoherent sources. Sources which emit emits light waves of different wavelength and having different phase. So this is a coherent source. Example, you can tell that. So any bulbs, okay? Bulbs, the monochromatic bulbs that what we use. So those are the incoherent sources. So monochromatic bulb sources. Next, coherent sources. Coherent sources. So it is opposite to the incoherent, which emits the light waves of same wavelength and having constant phase difference. Sources which emits light waves of same wavelength and having constant phase difference. So example for this can give eggs and double slits. Eggs double slits is an example for coherent source. Theory of interference. Okay, again, let's take as an example of two sources of light which is projected to a point. So this is the light coming from the S1 and from the source S2. So here are the two different phase difference, right? State of vibrations for the two waves are different. And I can find the part difference here, delta x, and phase difference will be there between them. So I will take the first wave, okay? The displacement of the first wave, S1p. So that I will take it as y1 is equal to a sine omega t. So this is the wave equation. So the wave which varies sinusoidally, we can express in this way. So I've studied in the first PU wave chapter. So similarly, we can write the equation for the second wave, but the second wave is not with the same phase, okay? For the same omega t angle, it is having some higher phase difference, right? So I can take sine omega t plus phi. So its state of vibration is different. Now, according to superposition principle, so according to superposition principle, the resultant displacement is equal to sum of the two displacements. Principle y is equal to y1 plus y2. So substitute the two values, a sine omega t plus a sine omega t plus phi. Take out the a common there and get sine of omega t plus sine omega t plus phi. Okay, now you can apply the formula sin A plus sin B. Okay, Use the formula sin A plus sin B. Formula is 2 sin A plus B by 2 into cos A minus B by 2. So I am using that. So A into 2 sin A plus B by 2. Omega T I taken as A and this is B. A plus B by 2. And cos A minus B by 2. Omega T minus of omega T. I'll multiply the minus sign to inside. So it will become minus. Understood? Therefore, y is equal to 2a sin of 2 omega t plus 5 by 2 and cos of, see here I get only minus 5 by 2. Omega t will be cancelled. So cos of minus theta is, cos theta only. Therefore, I can take this as a y is equal to 2a cos 5 by 2 into sin of 2 omega t plus 5 by 2, right? So this is the term which shows the resultant displacement. Correct? Observe observe the equation 1 and 2. Here the position A represents the amplitude of the wave. Amplitude of the wave is nothing but this, the displacement of the wave, right? So here also in this resultant equation, so this 2a cos 5 by 2 represents the amplitude position, resultant amplitude we can say. So further I can write that equation as, since considering R as the resultant displacement, 2a cos 5 by 2 and consider it as a resultant displacement. Therefore, the previous equation I can write as R into sin of 2 omega t plus 5 by 2. So just take it as a equation number 1. So by using this equation, so we can derive the conditions for constructive interference as well as the destructive interference. Now, condition for constructive interference. We already learned constructive andre ಹೇಗಿರಬೇಕು, intensity must be maximum, right? Crush should fall on a crust, trough falling on a trough, intensity will be maximum. So now we have to give the path difference and phase difference formula under the conditions of constructive and destructive. See, I know this resultant formula, right? This amplitude only ultimately matters, right? So if the amplitude is bigger, of course, it is a constructive interference. If amplitude is a smaller, then it is a destructive. So the main factor which decides whether the intensity is maximum or minimum is the R. Okay. So here, first I am finding here the phase difference. Under constructive interference, I am finding the phase difference. Okay. So for constructive, intensity must be maximum. Constructive interference, I is maximum. So resultant amplitude must be maximum. That decided by the factor cos 5 by 2, right? So it should be plus or minus 1, maximum value. See here in the positive scale it is plus 1, in the negative minus 1. So the cos value oscillates, maximum value on both the sides is plus or minus 1. So for what are the possible values, the cos gives either +1 or -1. We know right from the cos 0. Okay, we know that the cos 5/2. Okay, or for 5/2. Just I'll take for a 5/2. For 5/2 is equal to 0. Cos, see if I replace the 5/2 plus as a 0, cos 0, it is 1. Then pi value, pi means 180, cos 180 minus 1. Again 2 pi, 360, cos 360, again it is 1. Then 3 pi, 4 pi, okay, 5 pi, keep moving on. Therefore, if you multiply both the side by a 2, then you get the 5 value as 0, 2 pi, 4 pi, 6 pi, etc. So you can see here the phase difference is the multiples of the even number. Okay, therefore I can write the phase difference as a 2n pi. So where n is an integer, it can be 0, 1, 2, 3, whatever it is. See in the n place, if you replace the 0, you'll get the first term. If you take the 1, second term. If you take the 2, the third term, like that you get. So yeah, phase difference is a even multiple. Okay, even multiple of the pi. Or you can also say that it is an integral multiple of the 2 pi. So this is the phase difference condition under constructive. Similarly, we have to find the path difference. Path difference condition under constructive interference only. Okay. We know the relationship between phase difference and the path difference. Delta phi is equal to 2 pi by lambda into delta x. Therefore, delta x becomes lambda by 2 pi, correct, into delta phi. But the phase difference, we already derived it, that is 2n pi. Then 2 pi get cancelled. Therefore, delta x becomes n lambda. So this is the path difference. So path difference under constructive interference is the integral multiple of the lambda. Okay. So it is an integral multiple of lambda. So you can choose any values for a n here. N might be any number, 0, 1, 2, 3, any number. So if you get the question that mention the conditions for constructive interference, you have to mention these two. Okay, what is the phase difference? 2n pi. What is the path difference? N lambda. Now similarly, we have to derive the condition for destructive interference. Conditions for destructive interference. So destructive interference resultant intensity must be minimum, right? So let's find out here the phase difference. Now we are finding the phase difference under this. So intensity must be minimum. So take that cos 5/2 value, resultant displacement. No, so this value must be 0. Minimum means. So for what are the possible values? It gives 0. Cos 90 0. 270 0, right? That is 3 pi by 2, 5 pi by 2, 7 pi by 2, like this. Okay, so by cancelling the two twos on both the sides, taking common, therefore the phase difference 5 will become pi, 3 pi, 5 pi, so on. So you can observe here 1, 3, 5, 7, like odd numbers, odd multiples we are getting. Therefore, the odd multiples we can write it as a 2n plus 1 into pi. So this is the phase difference where n can be 0, 1, 2, 3, etc. So this is the phase difference for destructive interference. It is an odd multiple of pi. You can say odd numbers can be represented by 2n plus 1. And find out the path difference under destructive interference. So use the formula delta x is equal to lambda by 2 pi into delta phi. So delta x is equal to delta phi value 2n plus 1 into pi. So a pi will get cancelled, right? Therefore, delta x is equal to 2n plus 1 means odd multiple of the lambda by 2. So this is the path difference. Got it? So for a destructive interference, the path difference is odd multiple of lambda by 2. Here phase difference is odd multiple of pi. But for the constructive interference, phase difference is even multiple of pi, and your integral multiple of the lambda is the path difference. And this gives the complete theory of the interference. Please go through it once again. Information. So about coherent interference or sustained interference. Just know the meaning of this. Then what is the meaning of sustained interference? Sustained or coherent interference. See, we understood that from constructive interference, we get the bright fringes. From the destructive interference, we get the dark fringes. Okay. So if these bright and dark fringes remain fixed on the screen, okay, if it's not moving, it should be keep fixed to your screen. So then we call it as a coherent interference. So here interference is said to be coherent if the positions of bright fringes, position of bright fringes and dark fringes remain fixed. Remain fixed on the screen. Okay, then we call as a sustained or coherent interference. The example we can give Young's double slit experiment. Okay. So now the very important concept, Young's double slit experiment. Okay. So in this experiment, there is a single source slit. The slit is nothing but a narrow passage for the light. That's it. Okay. So it's just a narrow passage for the light to pass. So this is what we call as a source. source slit it is. So through this, the monochromatic light will passes. Monochromatic light means single colored light is allowed to pass through the single slit here, that is a source slit, and further it will fall on a double slits. So there will be a two narrow passages for the same light to pass through. The distance between the two slits, we can take it as a small d. Is the slit 1 and slit 2. So this is the double slit system. And from the double slit, after the light passed, okay, so due to the superposition of waves, so we can see the fringes here on the screen. Okay, we can expect the alternate bright and dark fringes. Okay. So what I am drawing here now, that is a bright fringe, and the middle portion is a dark fringe. So it must be of equal size and equal in width, equally dark and equally bright. Okay. So here there's a little width variation is there, but it should not be like that. Okay. So here are the fringes we are getting. So in between passages, what we are observing here, these are the dark fringe. Dark fringe. And what I drawn these boxes, these are the bright fringe. Okay. This is the screen. And the distance between the double slit and the screen distance, we have taken capital T. Understood? This is the Young double slit experimental setup. There will be a source slit. Through the source slit, one single colored monochromatic light will pass through it. It will fall on the two slits, and these two slits acts as a virtual sources. Okay, so through that, the superposition will occur on a screen. Due to the superposition of lights, okay, the constructive interference will give the bright fringes and the destructive interference gives the dark fringes, and at the middle always the bright fringes will form. Okay, so these are the information we have to give now. So let's write point wise one by one. So the observations are like this. So the interference pattern will have the following characteristics. The point number 1, the interference pattern has alternate bright and dark fringes. Alternate bright and dark fringes. There is no pattern like continuous bright, continuous dark. Okay, one bright fringe, immediately there is a one dark fringe. And the width of bright fringe is equal to width of the dark fringe. Width of the dark fringe. Third one, the intensity of all the fringes, means all the bright fringes is same. Okay, so all are equally bright. There is nothing like one is more bright, one is less bright. And similarly, the intensity, all the dark fringes, all the dark fringes. There is no intensity at all, pure dark it is. So it is 0. And you can also observe one more point there. At the center of the screen, at the center of the screen, always bright fringes forms. Bright fringe is formed. Very, very important to know why always at the center bright fringe is formed. This is because, no, what is the reason for this? Because at the center of the screen, the waves have zero path difference. Zero path difference and zero phase difference. Zero phase difference. Okay. So this is the reason highlighted at the center of the screen. Always when the two waves are meeting, there is a zero path difference and zero phase difference. And these are the characteristics of the interference pattern. Okay, in the Young's double slit experiment. So by using this, we can draw the intensity distribution curve. Intensity distribution curve. For interference it is. So this is the displacement and here is the intensity. Along y-axis, it defines the intensity, and along the x-axis, it is the distance from the center of screen. So this graph confirms about the characteristics of the interference pattern. So the intensity distribution curve shows that all the intensity levels are equal. Okay, that means where the intensity is maximum at the peak point. No? So this point represents the bright fringe formation, and where it touches the x-axis, these positions represents the bright fringe formation. Sorry, dark fringe formation. The peak point represents the bright fringe formation, and the position where it touches the x-axis, that gives the dark fringe formation. The meaning of fringe width is this. The fringe width is nothing but distance between the two consecutive bright fringes or dark fringes. Yeah, just I'll write the definition here. Make a note of it. Fringe width. What is the meaning of fringe width? Distance between two consecutive bright fringes or dark fringes. It's called the fringe width. Now the next derivation is that we are going to find the fringe width. Okay, so there is a derivation for phi naught in the last year came in the last examination. So most important. Yeah, this is the question. Let's draw the diagram for this. Okay, so there are two slits in the Planck's double slit experimental setup. And write the two slits here. Okay, I'll call this as a slit S1. And I'll call another slit as a S2. And the distance between these two slits is small d. And here I will take a screen. This is the screen located at a distance of capital D. Okay. And this is what I mark the central position of the screen. Let it be O. And I'll call this, yeah. So let us mark a point P here. So where the two lights from the two slits are meeting at that point. So I'm taking light from a S1, one more light wave from S2. Okay. So when I draw the normal from this point, it actually makes the central portion of the distance between the two slits. And I'll call this point as a Q. Okay. If I draw a perpendicular distance like this, I'm drawing a perpendicular distance here, then this length S2n gives the delta x. Okay. So here I can consider the angle theta. Understood? Later I'll take 1 minute. Okay. I hope you understood the diagram. Where D is the distance between the slits and capital D distance between the slits on the screen. And here at this point we get the fringe. So it is at the distance x. We can solve this derivation in two methods. One is from the arc distance method and one is from the considering the sine and tan ratios. Okay. Since we have path difference, I can write. So you look at the path difference. What is the path difference here? S2n, right? So that S2n is nothing but S2p, longer path minus the shorter path. So what it gives? So that is a delta x, right? So the delta x is nothing but here n lambda. If if here we are getting the bright fringe, but that will become a 2n plus 1 lambda by 2 if you consider as a dark fringe. So let's take for a bright fringe. I'll write here for bright fringe. N lambda. Now from the triangle, let us consider the triangle N S1 S2. So with respect to the slits here, so consider sine theta in that. Sine theta is nothing but opposite divided by the hypotenuse. Here hypotenuse is S1 S2. This is the S2 and is the opposite. So it becomes delta x divided by small d. So we can take it as equation 1 and consider the triangle PQO. Okay, this is the reference line what we draw. So from center to center, right? So there consider tan theta. Tan theta is opposite divided by adjacent. that is x divided by capital T. Okay, but for a small values of theta, for small values of theta, so sine theta and tan theta ratios almost equal. We can just consider them as a theta only, right? Therefore, the above equations we can equate from 1 and 2. Can equate them like this: x by d is equal to delta x by small d, right? Therefore, x becomes delta x capital D by D. Correct. Call it as a equation 3. Now we know the delta x value, right? So we can substitute the delta x value also in the next step. Yeah. So first I'll consider for the nth bright fringe. We already considered delta x as a n lambda for the bright fringe. For nth bright fringe, I can take the x portion as a xn. I don't know whether it is a 10th or 100th position. Let it be a nth position. And here delta x becomes n lambda because I'm considering the bright fringe. Therefore, the equation 3 becomes, I'm considering for nth bright fringe. Therefore, equation 3 becomes xn is equal to n lambda d by d. Okay, call it as a equation 4. Now we are finding the fringe width. To find the fringe width, we need at least consecutive fringes, right? So when I consider the xn, the next one is xn plus 1. So for n plus 1th bright fringe, n plus 1th bright fringe, I can replace the n by n plus 1. xn plus 1 is equal to n plus 1 lambda d by d. Call it as a equation 5. Got it? Now we are going to find the fringe width. Therefore, fringe width beta is equal to subtract the xn plus 1 minus xn. Therefore, beta is equal to n plus 1 lambda d by d minus n lambda d by d. Therefore, beta is equal to, take out the common, lambda d by d here. So n will be cancelled. So we get beta is equal to lambda d by d. Yes. I will explain once again. So look at this expression for fringe width. Consider the two slits at distance small d and screen is at the distance capital D. The two light waves are meeting at a point P. The fringe will form at a distance of x. Okay, and I'm drawing the normal reference line here in dotted lines, and it makes an angle theta. And here also we can expect the theta, right? And this is the delta x. Is the part difference. I taken as 2p minus s1p. That is n lambda for the bright fringe. Close the triangle ns1 s2. Find sine theta there. And in the next triangle PQO here, PQO. Here find the tan theta, it comes x by d. This is the opposite and adjacent. This OQ line, it is nothing but the distance. And for small values of theta, these two are almost equal. Therefore, you can equate the equation 1 and 2. X is equal to delta x d by d. Now consider for the nth bright fringe first. Substitute in the equation 3. And then n plus 1 the bright fringe. For the n plus 1 the bright fringe. And then subtract them. You will get the fringe width. Understood the derivation? See, this is the complete information about the interference. Let's check once again. So related to interference, interference of light, constructive interference, destructive interference, examples of interference, about the sources of light, incoherent, coherent, and theory of interference, condition for constructive and destructive. We found the formulas for path and phase difference in each cases. And then about sustained interference, example, Young's double slit experiment. Young's double slit experiment characteristics, the fringe pattern characteristics, and then intensity distribution curve, and finding the fringe width by using Young's double slit experiment. Yeah, that's all for today.